For thousands of years, humanity believed the Earth stood firm at the center of everything, under a beautiful glass dome of stars. But this cosmic picture wasn't easily won. It took intellectual rebellions, heresy trials, and the silent dedication of brilliant minds. In the 16th century, Nicolaus Copernicus dared to doubt. He was a humble cleric who spent decades observing the planet's strange wanderings. By placing the sun at the center, he shattered human pride and initiated a new era of thought, published only on his deathbed. Then came Galileo Galilei in 1609. He didn't just buy a telescope, he built the most powerful one of his era. He pointed it upward and saw a rugged moon and a Milky Way made of millions of stars, far beyond human sight. His most shocking discovery? 4 moons orbiting Jupiter. It was undeniable proof that not everything revolved around our own Earth. Galileo taught us that the universe speaks the language of mathematics. We must have the courage to look directly at the truth. Leaving the fierce debates behind, we meet Johannes Kepler, the man who decoded the universe's hidden mathematical laws. Kepler lived on the edge of mysticism and logic, believing the cosmos followed a divine sheet of musical harmony. He inherited a treasure of data from Tycho Brahe, forcing him to choose between his beliefs and the truth. For 8 grueling years, Kepler tried to force the orbit of Mars into a perfect, divine circle. But a tiny, 8-arc-minute discrepancy remained. In that gap, Kepler discovered the truth. Planets move in ellipses. His 3 laws of planetary motion shattered the old crystalline spheres, proving physical forces were at play. He proved planets speed up near the sun and slow down further away, establishing a strict mathematical relationship. Kepler laid the foundation for the next giant, Isaac Newton, who would finally unify the heavens and the earth. Newton's genius wasn't just wondering why the apple fell. He asked a question that would forever change how we see the world. Could the same force pulling the apple also keep the moon in its orbit? This thought bridged the gap between Earth and sky. In his masterpiece, Principia Mathematica, he introduced the law of universal gravitation, a simple equation for every particle in the universe. This was the greatest unification in science. For the first time, we understood the universe as a single, unified entity. While Newton redefined force and motion, Christian Huygens was across the channel, exploring the subtle complexities of light and distant worlds. Huygens decoded the mystery of Saturn. He realized it wasn't ears, but a flat ring detached from the planet's body. He didn't stop there. Huygens discovered Titan, Saturn's largest moon, a world with its own strange atmosphere and liquid lakes. His most enduring contribution was the wave theory of light. He proposed light travels as waves propagating through space. Huygens even attempted to measure the staggering distances to stars by comparing our sun's brightness to theirs. A visionary leap. In the 18th century, William Herschel, a musician turned astronomer, revolutionized our understanding of the cosmos's immense scale. In 1781, Herschel discovered Uranus. This event instantly doubled the known size of our solar system, shattering ancient beliefs. With his sister Caroline, he embarked on an audacious mission, mapping the entire Milky Way by counting millions of stars.
Millions.
Herschel sketched the Milky Way as a flattened disk, realizing our sun was just an ordinary star within this vast island universe. I have an idea. Let me show you what I mean. He shattered the dogma of perfect celestial spheres, observing a moon scarred with rugged mountains and deep valleys. This lunar surface looked startlingly similar to our own Earth, proving the heavens weren't as alien as believed. Gazing at the Milky Way, he discovered it wasn't a faint smear, but a dense convergence of millions of stars. His most shocking revelation came when he spotted 4 small moons actively orbiting the giant planet Jupiter. This provided the first empirical proof that not every celestial body in the universe revolves around the Earth. By documenting the phases of Venus, Galileo delivered the final, undeniable evidence supporting the heliocentric model. Galileo became the steadfast storyteller of objective truth, a man who dared to see the universe as it truly is. Copernicus unleashed a truth so powerful it shook the very foundations of our world, forever shattering our primitive illusions of existence. By crowning the sun as the center, he didn't just map the stars. He fundamentally redefined humanity's place in the infinite cosmos. This sparked a revolutionary era of thought, forcing us to finally accept that we are not the universe's grand focal point. We are but a tiny gear in a much more massive celestial machine, one that operates with breathtaking, clockwork precision. Now, meet Galileo Galilei, the observer of objective truth, who would transform these radical theories into undeniable, physical reality. If Copernicus was the architect who drafted the new cosmic map, Galileo was the daring pioneer who first explored it. He forged the most powerful telescope of his age, ready to pierce the heavens and dismantle ancient dogmas once and for all. Galileo didn't just look, he saw. He pointed his lens at the moon, shattering the myth of celestial perfection forever. Instead of a smooth orb, he found a world of rugged mountains, deep valleys, and dusty craters, much like our Earth. The Milky Way revealed its secret. Not a faint smear of light, but a dense convergence of millions of individual stars. Then, the ultimate shock? 4 moons orbiting Jupiter. Proof that not everything in the universe revolved around our tiny Earth. For his truth, he faced the formidable Inquisition, a steadfast storyteller of objective reality, refusing to blink in the face of power. Even blind and under house arrest, he never ceased pondering the laws of motion, an immortal symbol of the scientific spirit. But the heavens held more secrets. Enter Johannes Kepler, the man who would decode the divine geometry of the cosmos. Kepler lived on the boundary of mysticism and logic, searching for the hidden mathematical laws that governed the planetary dance. Kepler's laws shattered the ancient idea of crystalline spheres, proving that planets accelerate as they sweep closer to the... He replaced the myth of angels pushing planets with the reality of tangible physical forces, bringing order to the heavens. Enter Isaac Newton, the genius who would finally bridge the gap between the Earth and the stars with one law. The story of the falling apple isn't just a legend. It marks the moment human perception changed forever in an orchard. Newton asked, could the same force pulling an apple to Earth also be what keeps the moon in its celestial orbit? He boldly erased the boundary between our changing world and the supposedly perfect, immutable realm of the distant stars. In his masterpiece, Principia Mathematica, he unveiled the law of universal gravitation, a single truth for all matter. Newton transformed the mysterious cosmos into a grand, predictable clockwork machine, governed by the elegant precision of natural laws. Newton proved that the same laws swinging a pendulum in a lab also govern the dance of distant galaxies. This grand unification revealed a single, unified universe, where the same rules apply from our world to the stars. His mathematical framework for mass and force provided the key to unlocking the behavior of every object in existence. From the rhythmic tides of our oceans to the wild paths of comets, Newton's vision explained it all with ease. He even calculated the Earth's bulge at the equator, turning the art of stargazing into a rigorous, exact science. The universe no longer required supernatural nudges. It ran itself through the cold, beautiful logic of immutable natural laws. This discovery gave humanity a new perspective, a mix of profound humility and the power to understand the infinite. Christian Huygens, the messenger of light. While Newton mastered motion, Huygens set out to decode the mysteries of light. Huygens was a brilliant polymath, a master telescope maker who elevated sky observation to unprecedented levels of detail and precision. He successfully decoded the mystery of Saturn. Since Galileo, it had appeared with bizarre, shifting shapes, looking as if it had ears. Huygens realized Saturn was encircled by a flat ring. He didn't stop there. He also discovered Titan, Saturn's largest moon. His most enduring contribution was the wave theory of light. He proposed that light traveled as waves propagating outward through space. Huygens was the first to attempt measuring the staggering distances to stars by comparing our sun's brightness with other celestial bodies. In the 18th century, we meet William Herschel, a musician turned astronomer who revolutionized our understanding of the cosmos's immense scale. Dissatisfied with existing telescopes, Herschel took matters into his own hands, independently casting and grinding massive mirrors for his instruments. In March 1781, Herschel's telescope landed on a strange object, Uranus. This discovery shattered the ancient belief in only 5 planets. But Herschel's ambition pushed him to look even further into the void. Supported by his sister Caroline, he embarked on an audacious mission, mapping the entirety of our home, the Milky Way galaxy. By counting millions of stars, Herschel sketched the Milky Way as a flattened disk, placing our sun as just one ordinary star. Beyond mapping, Herschel discovered infrared radiation, proving the existence of light invisible to the human eye, opening a new cosmic window. Through his lens, the sky became a deep, three-dimensional forest, teeming with nebulae, binary stars, and the ancient mysteries of time. With the heavens charted and gravity established, a larger question surfaced. Where did all this complexity actually come from? The brilliant French mathematician Pierre-Simon Laplace took up the challenge, seeking answers through the absolute power of logical reason. In his massive work, Exposition of the System of the World, Laplace detailed how the solar system naturally formed from spinning gas. Laplace reasoned that a massive cloud of gas collapsed under gravity, spinning faster and flattening into a rotating disk. From this disk, rings of material were shed, eventually coalescing into the planets we know today. Known as the French Newton, he proved that minor gravitational wobbles would naturally self-correct over vast stretches of time. This ensured the long-term harmony of our cosmic neighborhood, replacing the need for constant divine intervention. But his boldest prediction was the dark star, a body so dense that even light could not escape its pull. Centuries before their confirmation, Laplace had mathematically conceptualized the intense reality of what we now call black holes. In the 19th century, philosopher Auguste Comte claimed the chemical composition of stars would remain an eternal secret. That secret was shattered by Joseph von Fraunhofer, an orphan glassmaker who found the master key to the cosmos. While meticulously studying glass properties, Fraunhofer dispersed sunlight through a prism and stumbled upon a cosmic secret. Hundreds of mysterious, fine, dark lines were etched across the brilliant rainbow spectrum, like a hidden code. He realized these dark bands weren't flaws in his lens, but a profound message transmitted directly from the stars. Decades later, Kirchhoff and Bunsen cracked the code, proving every chemical element leaves a unique spectral fingerprint. These lines were the smoking device, proving stars are forged from the same elemental building blocks found on Earth. Hydrogen, helium, and iron, the celestial chemistry of the distant stars, was finally, incredibly, within our grasp. As spectroscopy burst, the data became an unmanageable mountain. It was time for Annie Jump Cannon to bring order. Annie Jump Cannon stood before a mountain of data. Harvard's computers were drowning in starlight, and she needed a system. Deafness couldn't stop her. Her eyes were her special ability, finding hidden patterns in the messy spectral noise. 300,000 stars. She analyzed every single one. It wasn't just work, it was a marathon of the mind. She boiled the chaos down to 7 letters: O, B, A, F, G, K, M. Simple, elegant, and revolutionary. Those letters unlocked the stars' secrets, linking their light directly to their scorching or cool temperatures. Her catalog became the Bible of astronomy. She didn't just sort stars, she mapped the very life of the universe. But the quest for scale wasn't over. Enter Henrietta Swan Leavitt, the woman who would finally measure the heavens. Henrietta hunted Cepheids, stars that pulse like cosmic heartbeats. She was searching for the ultimate ruler of space. Joseph von Fraunhofer, the fingerprints of the stars. For centuries, scientists were limited to observing only the stars' positions and movements. Philosophers even declared the stars' chemical makeup an intrinsic secret, forever beyond human grasp. But Joseph von Fraunhofer, an orphaned glassmaker, accidentally found the master key to the cosmos. He dispersed sunlight through a prism, revealing hundreds of fine, dark lines across the brilliant spectrum. These Fraunhofer lines were not flaws, but a special message from the stars themselves, later deciphered by Kirchhoff and Bunsen. Every element creates a unique spectral fingerprint, proving stars are made of the same building blocks as Earth: hydrogen, helium, iron. This breakthrough revolutionized astrophysics, transforming it from geometry into complex chemistry and physics. Starlight is a richly encoded message. With the knowledge to read it, we can unlock the physical nature of entities billions of miles away. At Harvard, Annie Jump Cannon and her team, the Harvard Computers, undertook an unimaginable volume of analytical work. Despite near-total deafness, Cannon possessed incredibly keen vision and an innate, unparalleled talent for classification. She refined stellar data into a simple sequence, O, B, A, F, G, K, and M, mapping the life cycles of stars. Her legacy remains the standard today. But another brilliant woman at Harvard was about to measure the very scale of space. Henrietta Swan Leavitt focused her research on pulsating stars called Cepheids, searching for a pattern in their rhythmic flickering. She discovered that the longer a Cepheid took to pulse, the more inherently luminous it actually was. This period luminosity relationship turned these stars into standard candles, beacons to gauge the staggering distances of the cosmos. Leavitt's cosmic ruler allowed us to finally see the true scale of our reality, revealing a universe of billions of galaxies. From the moment Copernicus dared to move the Earth from its unmoving center, to the day Henrietta Leavitt forged a ruler made of light. The restrictive, ancient glass dome of the heavens has been completely and irrevocably shattered. Humanity finally awoke to the reality of its place, floating beautifully within an ocean of billions of galaxies. But just as we began to grasp this mind-bending vastness, another earth-shattering revolution was already on the horizon. We stand on the precipice of a new era, where time itself can be bent and space can physically stretch. The entire universe traces its intense birth back to a blinding energy burst. Welcome to the relativistic era, where the very fabric of reality begins to stretch and bend in ways we never imagined. Albert Einstein didn't just change physics, he rewrote the rules of the universe, proving that time and space are one. Imagine a universe born from a single, blinding energy burst, expanding outward into the infinite void of nothingness. Galaxies aren't just floating, they are racing away from each other as the space between them physically grows. Time is no longer a constant. It slows down near massive objects, ticking differently for every observer in the cosmos. Even light, the fastest thing in existence, cannot escape the curve of space-time created by the weight of stars. At the heart of this mystery lie black holes, regions where gravity is so intense that reality itself seems to break. Prepare to have your mind expanded as we explore the mind-bending truths of Einstein's revolutionary vision. Welcome to Episode 2, The Relativistic Era. We are about to transcend the limits of classical physics and enter a new reality. We stand on the precipice of a revolutionary age, an era where the very fabric of existence is redefined by pure genius. In this world, time is no longer a constant. It is a flexible dimension that bends and warps under the weight of gravity. Space itself becomes dynamic and alive. It can physically stretch and ripple like the surface of a vast, cosmic ocean. We trace the entire universe back to a singular, intense birth, a blinding energy burst that set the stars in motion. Step into the extraordinary world of Albert Einstein. His mind-expanding theories shattered our most basic perceptions of the cosmos. Join us as we explore these mind-bending realities. Discover how one man's vision changed the course of human history forever. The journey into the relativistic era begins now. Are you ready to see the universe through Einstein's eyes? Welcome to Episode 2, The Relativistic Era. Here, we shatter the clockwork universe and embrace a reality far more bizarre. At the heart of this revolution stands Albert Einstein, a man who dared to question the very nature of time and space. Einstein wasn't just a mathematician. He was a dreamer who saw the universe as a flexible, dynamic tapestry. He proposed that space and time are not separate, but woven together into a single four-dimensional fabric called space-time. Gravity, he realized, isn't a mysterious force pulling objects, but the curvature of this fabric caused by mass. In 1919, a total solar eclipse provided the perfect stage to test this radical theory before the entire world. As the moon blocked the sun, astronomers observed starlight bending around its mass, exactly as Einstein had predicted. Overnight, Einstein became a global icon, proving that even our most fundamental certainties can be rewritten by a single mind. Einstein didn't just win a Nobel, he triggered a mental earthquake, turning our solid world into a cosmic illusion. He reimagined gravity not as a force, but as the very geometry of a flexible, four-dimensional fabric called space-time. Think of a heavy bowling ball on a trampoline. That's the sun, curving the very path of everything around it. Planets aren't being pulled by invisible strings. They're just sliding down the invisible slopes of a warped cosmic landscape. Suddenly, time was a variable, and the universe was no longer a static machine, but a living, breathing entity. Yet, his own math whispered an intense secret. The universe was moving, either exploding outward or collapsing inward. Terrified of a dynamic cosmos, he added a fudge factor to keep it still, a mistake he'd later call his greatest. But the truth couldn't be hidden for long. A new giant was rising, ready to measure the impossible. Welcome to the dawn of a new understanding. We are entering the relativistic era, where space and time are no longer fixed. Henrietta Leavitt worked tirelessly at Harvard, her eyes scanning thousands of tiny, flickering dots on glass plates. In 1923, he spotted a Cepheid in the Andromeda Nebula. It wasn't a cloud, it was a whole other galaxy. Suddenly, our Milky Way was just one island in an endless ocean of billions. The scale was truly mind-blowing. At Mount Wilson, Edwin Hubble was rewriting the map of the heavens, proving that our galaxy was just one among billions. He saw the light from distant nebulae shifting to red, a clear sign that they were racing away from us. If the universe is expanding today, it must have started from a single, incredibly dense point in the distant past. We had broken the heavens, the glass dome was shattered, and we were finally looking into the true face of infinity. This wasn't just a change in science, it was a change in the human soul. We were no longer the center. Welcome to Episode 2, the relativistic era. Here, time and space are no longer fixed, but a single, flexible fabric. Prepare to meet the man who bent light and redefined gravity. The journey into the mind of Einstein begins now. Henrietta Leavitt's cosmic ruler didn't just measure stars, it shattered the final walls of our ancient cage, revealing a universe without end. The ancient glass dome of the heavens lay in ruins. We were no longer central, but part of a vast, expanding ocean of galaxies. Welcome to Episode 2, the relativistic era. Here, the very fabric of reality begins to stretch, bend, and finally, burst into being. Enter Albert Einstein, a man whose imagination was so powerful it could reshape the laws of gravity and the flow of time itself. He saw space not as an empty void, but as a flexible stage, where mass tells space how to curve and warp. This new vision led us back to a singular moment, intense, blinding birth of everything we see, from a tiny, infinite point. Edwin Hubble then proved the universe was growing, carrying galaxies away on a tide of expanding space that never seems to stop. Prepare your mind for the next leap. The journey into the relativistic heart of the cosmos is just beginning. Let us proceed. From Copernicus's bold defiance to Leavitt's cosmic yardstick, the ancient glass ceiling of the heavens has been shattered forever. Humanity has finally awakened, finding our home in a breathtaking ocean of billions of swirling galaxies. Yet, as we embrace this vastness, a new, mind-bending revolution is already dawning on the horizon. Prepare for an era where time warps, space stretches, and the universe begins with a blinding, intense energy burst. Thank you for watching Powerful Impact That. Like button and subscribe to join our next epic scientific adventure. Connect the bell to stay updated. Your curiosity fuels our exploration of the great unknown. See you soon! Goodbye, fellow travelers. Keep looking up, and we'll see you in the next chapter of cosmic history.